So good evening, everybody. Today, I will deny everybody the opportunity to say the introduction and say it myself because Shajan is a very special person for me. We studied from KG to engineering college final year together, except for the two years that he was in Marivanis. So it's a long journey together. But sometimes you have some people in your life, you really don't know whether you never talk about them being there. Only when you want to talk about it, you really think about it. So Shajan is one such person. He has been like a silent friend who has been always there for each one of us, and you come to know about it only through some interactions or some incidents. Okay, so quickly I'll tell you some background because he'll tell you what he has gone through from college to now, but I'll tell you something about school days. So at school, he was the NCC cadet corporal. He was the head of NCC. He was a basketballer. He was an athlete, a very silent person, a topper in the class, and one of the toppers in the class. And he made it to, him. He's a self-made person. All his efforts on his own, he made it to computer science. There also, I'm sure, he was a part of the college chess team, and he progressed well. There is another part where I should say he's been part of my journey is that while in college, while we are in college politics, uh, it's not, many people don't know, elections are fought very in an organized manner. There is a party machinery that actually supports. Candidates do nothing. They just are faces in behind it. So Shajan was the head of the party when I won the election. So I know the machinery that goes behind and the sort of leadership that he has to give. And I know the silent support that came from him all throughout in all throughout my space in engineering college. So this said, he has moved on to be an excellent engineer. He's somebody who's always reachable as a friend. My kids have taken mentoring from him. It's always available on as a friend to everybody. So I'm very proud of being knowing Shajan and being part of him being part of my friend circle. A very true friend and a very valuable person. Today, I'd always look forward to this session. When we did all this CPC, I always wanted him to share. I've seen him speak at the our CGP unit speech when he gave some mentoring to the students. So a lot of knowledge and a lot of insight that's going to come from him. And I thank Shajan for having volunteered at short notice. So that shows how much he comes forward and supports when in need. So over to you, Shajan. Thank you and it's a great privilege to introduce you as well. Thank you. Over to you, Shajan.
Thank you for the generous introduction. Again, like as Wahid has mentioned, I'm filling in for Endeavor. It's not like oh, what happened? Okay, so this is on short notice. So my slides are not going to be like super flashy, but it's going to have the information. Once again, thanks all for joining today. I know you all have busy schedules and busy life going on, as well as people who are going to watch this recorded version. Thanks for spending the time with me here. I'll go through a few things. I'll go through my background, my family, two of my passions. One is programming and working with computers, and the other one is around strength training. And if you came here For the modeling part, it's all about the model in this context is machine learning models. So sorry to disappoint you. So that was a clickbaity title there, but I think you all understand that. So a little bit about me, my family. I have two kids. My son Vidul, he's on his final year of engineering. He took urban planning. I don't know what it is. I think it has something to do with helping companies navigate the city planning and things like that, or working in the cities. But unfortunately, there's not a lot of jobs. So he's graduating this year. If any of you have contacts with companies or cities that need a city planner with fresh graduate, do reach out to me. I'll appreciate that. So that's my son, Vidul. He wanted nothing to do with computers because, I work with computers and he hates computers. And my daughter, Vrinda, she's getting into college this year, and she doesn't really know what she wants to do. So I said, like, hey, if you really don't know what you want to do, and if you don't hate computers just because I'm working on it, then take CS. And she agreed to it. She's a little bit more agreeable than my son. So she's taking CS this year. She's trying to find a college she's going to college next year or later this year. So that's my daughter. And my wife, Rashmi, she had a short stay at Microsoft, and she's not working right now. She's from Pandalam, or she's from Kerala, basically. And we have a dog. We have a small dog. Her name is Janu, and she's 10-year-old. She has been with us for all 10 years. She's getting old. That's about my family. We live in Seattle, or we live near Seattle. It's about a 20-minute drive to Seattle city. On a day without traffic. With traffic, it's an hour and a half to Seattle. So Seattle is a beautiful place. It's like Kerala in the sense that it's very green. So if you're in the US and you're visiting Seattle, do look me up. There are a lot of things to do in Seattle if you're an outdoor person. There's a lot of hikes. It's generally a beautiful place to live. The only problem with Seattle is it rains. It's cloudy a lot. So 3 to 4 months a year, it's very cloudy and you hardly see the sun. I'm kind of used to it, but we are planning on moving out of Seattle. Once my daughter goes to college, then there's no point living here. So next few years for us is going to be just traveling and figuring out where to set our roots next, because we are done with Seattle. So that's about Seattle. It's a good place to visit, but it's not a great place to live for the long term, if you care about the sun. I work at Twitter, and if you have not used Twitter, please do. It takes a few years to understand, the value of Twitter, but once you understand the value of Twitter, you'll keep using it. Even for me, it took a few years to really understand. So to give you an example of why Twitter is useful is my wife hardly ever uses Twitter. The only time she uses Twitter is when there's a football game going on and she wants to see the commentary, what other people are talking about, something that happened on the game. Or so right now, like she's using Twitter to see like when the college admission results are coming for each college. It's posted on Twitter, and it's a good tool to know what's going on around you.
Looking for Twitter, and he's telling everybody should start using Twitter. I'm just listening today. CT. Yeah. Oh, sometimes.
Yeah, Twitter
Shajan,
right now.
Shajan, somebody really is waiting to use Twitter. Why don't you let him in?
It's free, by the way. Yeah, so at Twitter, I work on machine learning, and I'll speak a little bit about machine learning and how I got there. So I've been a programmer for a very long time. Let me provide some history. So somewhere in the mid 80s, I think I was in the 7th grade or even maybe even earlier than that. So I started doing this for no reason. I don't really remember why I did this. I started adding numbers like, 1 plus 3 odd numbers. And do you see any pattern here? Like anybody recognize a pattern here? You can guess, or you can actually.
It gets repeated.
Yeah, it is a repeated sum. And as a young kid, I really don't know why I kept doing this. And if my kids do this, I'll be a little bit concerned. But the pattern here is like you end up with perfect squares. So if you sum odd numbers, it'll always be a perfect square, and you'll get the next perfect square if you just add the next odd numbers. So I'd be really concerned. Like I remember there was a talk previously by someone in CPC where they recognized autism in kids. They were able to recognize it, but they couldn't tell the parents because of the school system doesn't allow them to do that. So this is kind of a sign of autism, if you ask me, but I think I turned out okay. So there's a story behind this. So I did this and I wasted a lot of time as a kid trying to see if this works for larger numbers. So, it's very expensive. You have a calculator, you keep adding numbers, you have to write it down. You make one little mistake, you have to correct it. And I didn't know, I didn't know enough math to actually know whether this works or not. I just knew that it happens to work. Now we're all, later on, like it's very easy to show this in algebra that if you write the formula for sum of odd numbers, you'll see that it'll come out as a perfect square algebraically. But you don't know that as a 7th grader or 6th grader that this is actually a simple mathematical thing. So I ended up wasting a lot of time. And this is around that time I had access to what we call a home computer, where I kind of read about programming, and the very first thing I did was try to write a program that does this, and so that I didn't have to write all these things down. And I wanted to see whether this works or not with big numbers. So programming for me it actually solved a real problem for me. Till then, when I was learning things in school, most of the time I didn't really understand why I had to learn this thing. Like for instance, they make you in your English and Malayalam and Hindi class, they make you by heart like a poem or paragraph of things. I never understood why you have, what does that teach you? I was a bit frustrated about those kind of things. And maybe there's a purpose to it. I just still don't get it. But a lot of what I learned like really didn't click with me. But programming, on the other hand, the first time I learned to program, it actually solved a problem for me personally. And this was again around my 8th grade or 8th or 9th grade. I don't really remember. So I wrote the program. I could see that sum of odd numbers starting from 1 is always a perfect square. And I also learned that there is something called arithmetic overflow. If you keep on doing that, your computer will run out of the number width and you'll get an overflow. At a very early age, I knew, as soon as I learned programming, I also knew about arithmetic overflow. So it was a natural thing for me. And anybody recognize this thing here? These kids these days won't, but so this is, when I started programming, this is where the software was. Like this cassette player, it had the actual data. Like this is how it worked. So this is actually a software cassette. It actually have bits and bytes in the tape. So this is how it used to work in the mid 80s. And I don't know how many of you have used this, but the way this works is you put the cassette, your software cassette in your tape recorder or tape player. You connect the audio output of the tape to your computer, your home computer, which is just that keyboard. Like that keyboard you see on the screen, it's the actual computer. Like it has a keyboard, it has a CPU and all inside it. And then you play the tape, you rewind the tape and play it. And there's a command that you run on your computer, and it'll wait like 20 minutes or however long the tape takes to play. And then it'll say, oh, the program is loaded. Then you can kind of use that program. It was quite hard because sometimes after 20 minutes, it'll say that, hey, something went wrong. And then you have to rewind the tape and play it again. And then it might load. Sometimes it's quite frustrating to load a program. These days in your phone, like if you have a phone, you just install an app and that's it, and you can use it. You know, that times have changed. So this is how I started programming, like using this this mechanism, mid-80s. So after this struggle with these computers, I mean, back then it wasn't a struggle because, you know, that's the only thing I knew. It was very cool, and you know, you could program. It meant the world to me. So after that, I went to PDC and then got into CS engineering with you all. And you know, after CS, I continued learning stuff. Now, one thing I want to call out is in CS at engineering college, I think I got my money's worth. You know, we hardly paid any fees, but I kind of enjoyed a lot of CS classes because I just like, you know, it clicked with me. Like I kind of found it valuable since I knew by the time I got into CS, I was already programming for, I think, 6 years or so. So I kind of, so when they taught like certain things, I was, oh, see the actual science, it made sense. So we had good professors, Mohan sir, or HOD. There's another, quite a few good professors who could actually tell you like, you know, this is how it works, and, you know, it made sense. There were also other boring classes, even some of those boring classes, non-CS to me, actually helped me in my career later on. For instance, the toughest class that I've taken in engineering was, there was an industrial systems or control systems engineering class. I don't know if any of us remember it. Like, kudos to people who take and are good at these things, mechanical engineering, industrial engineering folks. Like, I have a lot of respect for you because that class was really tough for me, and I hardly passed it. But later on in my career as a distributed systems engineer, I could apply some of those principles that I saw in that class, because it's kind of like a control system in distributed systems. With computers, with distributed systems, there are a lot of problems where there are parallels in control systems that actually helped me. So I wish I kind of paid more attention and put in a lot more effort during my engineering days to learn that. Another thing that helped me outside of CS was there was a math class in the first year. It's actually like with Fourier series and Fourier analysis, things like that. Again, like I didn't understand a thing back then. I could solve the problem. They give me a problem and how to solve it and give the answer and, you know, pass the test and all those things. But I really didn't know what was going on. But I had to relearn that. I think a lot of communication engineers are good at this. People who did the electronics and communication or applied electronics. This has to do with signal processing, and CS uses that for video processing and image processing, things like this. So I had to relearn it, and I wish, like, yeah, hey, non-CS classes, if I had just paid attention to it, I could have been, you know, saved a lot of time learning these things again. So that's, going to engineering college actually helped me quite a bit. I used like a lot of things I learned there, all the way from working on compilers and programming languages and things like that. So my career progressed as an individual contributor. I was a manager for a few years, and I hated it. So I went back to doing what I'm good at, which is programming and solving working with computers, I can. Working with people, it's a little bit harder for me. So I've stayed an individual contributor. I've been programming for, at this point, like 35 plus years. And that's my trade, and I'm good at it, I think. So I started working in my career. I went to Wipro. I started working on networks. I think most of you know what this is. But briefly, if you don't wonder what a network engineer, at least the thing that I do. So we write software that makes computers communicate with each other. Basically, that's about it. And I say a computer, it could be your phone or whatnot. Like at the time, I worked on network devices. So that's how I started my career at Wipro. Then I moved to Microsoft, I think, 98. I got a lucky break when I joined Microsoft. Yeah. Was there a question? No, okay. So I got a good break.
Sorry, I have a question, Shajan.
Go ahead.
When you say you had this old type in 80s, you said programming, but then as you moved out, which old languages actually you just brushed through to come to this profiles? What do you handle?
So when you're working on computer networks, it's usually C. It's raw C. Sometimes C++ as well, depending on which layer you're working on. So earlier on, like the first language I learned was BASIC. There was a language called Zingler BASIC. That's the first thing that I learned. It's very simple language. And later on then I learned a little bit of, I think the next thing I learned was Pascal in college. In CS, we learned Pascal. The interesting thing is when I was working at Microsoft, I worked with the creator of Turbo Pascal, Anders Heilsberg. After Pascal, I learned C and then C++. C++ to me was like kind of like awesome, because till then you're writing C and you didn't really understand object-oriented programming. As soon as I learned C++, it kind of clicked object-oriented programming for me. After that, I didn't learn anything new till a little bit of assembly, because sometimes you have to patch things up. The main language that I learned after that was Java, when Java came out. Then after that, I worked on C#, like creating the language itself. So that's Microsoft. Like when I joined Microsoft, they had a legal issue with Java. Like they were not allowed to develop or extend Java. So there was Sun Microsystem owned Java at that point, and they were having a big legal fight with Microsoft to keep the language independent. So Microsoft decided to fund a new language. That's when I just joined Microsoft at the right time, at the right place. So I was in the team that was creating a new language. It wasn't called C#, it was called something else. And then later on, like they rebranded it as C#. So I got to work with like quite a lot of smart people. I was one of the very junior member in that team. So I met Anders Heilsberg in that team. Like he was the lead architect for C#. I didn't know who he was. Like I used to get into meetings with him, and he would always like have, I would come up with ideas on how to structure this type system and all. He would say, that's all good, but here's another way to do this. And it was quite frustrating. He was always right. And I knew that. And he always rejected my ideas. And then I looked him up and I said, oh, he created Turbo Pascal. He must be really good. So I learned quite a bit directly from him as well, working on programming language. Quite a smart guy. And there were quite a lot of smart researchers, language researchers who are like all known in the industry, working on C# at that time. So being a junior most member in something like this kind of boosts your career, because you learn quite a lot of things in a very short amount of time. So that's my first break I got, was working on this at Microsoft. So language-wise, later on, I learned other languages like PHP. It's one of the terrible languages. Don't use it. PHP, it's not even thread safe. And then I learned a lot of things. I think Python is the latest one that I learned. It's a pretty good language. it's yeah, I'm quite impressed with what Python can do with respect to machine learning. Yeah, the most frequent languages that I use, the ones that I like really I like Scala quite a bit. Scala is a very good language. It works on the JVM runtime. So I use Scala, Java, and Python these days, and some C++ as well. So that's programming language. I worked on it for a little while. So I'll explain programming language, the work we do, in the following way. A programming language is a way you communicate with a computer. Like I know this is all basic for everyone, but if you're a human and you want to tell your computer what to do, you have to do that through a programming language, because computers need precise steps. So let's say you imagine solving a problem. You have to translate your ideas into a way that computers understand. You have to say every step that needs to be done, and you do that in a language. And the language designer's job is to come up with a way that programmers can express these things. So that's program. There's a reason I explained it this way. It will come later. So I worked on programming languages, then distributed systems. Once again, many of you know what this is, but sorry, my throat is getting dry. So you have problems in computers. Like I was working in search, creating a search engine for Microsoft for Bing. So you can imagine you need a lot of computers to solve these problems. Basically create an inverted index. Index is just like your dictionary index. Look up, every word has a list of websites that has that word in it. So you cannot store that whole thing in a single computer. You need thousands. Actually, we had 200,000 computers that held the Bing index. So when you have a lot of these computers, you have to write software that can manage these problems very well across computers and things like that. Distributed systems is the area of computers, in our industry, where deals with working with many computers and solving problems. This is where the control systems engineering actually helped me, the concepts there, because things can get destabilized and a lot of bad things can happen. So that's distributed systems. Another aspect of this is, as you might imagine, if you have too many computers, each drawing like 500 watts of electricity, and sometimes 1,000, you cannot put all of them in your office, right? So you won't have enough electricity from your city to pull, and it'll burn your office down because it'll generate so much heat. So you need to put those computers in a place where there is enough cheap electricity and cooling as well. So you put those things somewhere else in a warehouse where there is cheap electricity, and then you put your software on it from a remote place. And that's what is called cloud computing, and that's a fancy term for it. So I worked on all of those things for I want to say about 10, 12 years of my career was spent in distributed systems and cloud computing, both at Microsoft and later at Twitter as well. Then I joined Twitter. From Microsoft, there was a short period where I worked on a gaming company that makes games. But then I moved to Twitter, where I've been working on a few different things. So I started on working on Android, Twitter, and I was hired as a backend engineer. But when I joined, there was a shortage of Android engineers at Twitter. So I took a 1-week class. And again, being good at programming helped here, because after a week of class, they let me code. And the Twitter app worked. I mean, the app was already there. I was making improvements to it. So being good at programming helped. So you can work on any areas there. After Android, I worked on the Twitter video backend. So I was one of the people who created videos on Twitter. So you have a distributed systems backend that does video transcoding. And that's where the whole signal processing and Fourier transform, all of those things I had to relearn to do this more, do the actual work. And then I went on to machine learning. So I've been working on machine learning for the last about 3 to 4 years. So you remember, I'll explain what machine learning is in my own terms. And I know most of you are familiar with it, but let me explain. So you remember I described what programming language is. It's a way for developers once a developer has a programmer has an idea, okay, I want to solve this problem. These are the exact steps that's necessary to solve the problem. I'll write it in a program and let the computer execute it. But there are many problems where you cannot come up with the steps. Like there are very complex problems where it's very hard for a programmer to come up with the precise steps or the algorithm to solve a problem. This is where machine learning comes in. Machine learning is a technique where for problems of those nature, where it's very expensive to come up, or it's impractical to come up with these steps, you use machine learning where you depend on a piece of software, machine learning software, to figure out what those steps are. So as a programmer, you don't have to do these steps. You just have to program the machine learning software. So that's the difference between programming and machine learning. So to summarize, for machine learning, you depend on software to figure out the rules to solve a problem. With programming, you have to use your brain and solve the actual problem. So that's the difference. And for example, let's say you have a problem. For the problem you're trying to solve is you're looking at a picture. You have a software that needs to look at a picture and of a face and say whether it's a female or male. Like, think about writing a program to do this. What are the rules? What is the algorithm to find out whether a given set of pixels or given picture is a male or female? It's quite hard. Like, it's really hard to program it. You might be able to, but who would fund it? Like, programmers are very expensive on an hourly basis. Who's going to pay all that programmers to write this algorithm, which may or may not work? So it's a very expensive proposition if you go the programming route. It's much easier. It's actually quite simple if you use machine learning to do something like this. And again, for folks who already know machine learning and my CS friends on the call, this might be an oversimplified version of it, but I can explain machine learning in a few minutes, at least my version of it. In machine learning, what you do is you have a piece of software that is your machine learning kernel or your machine learning software. That's many available. All you do is you give the machine learning software a question and an answer and the correct answer. And you give it a lot of those, a lot of different questions and a lot of correct, a lot of examples of what the correct answer should look like. And the machine figures out the rules over time. So you sometimes, depending on the problem, you may have to give it 10,000 example or 100,000 or 1,000,000 examples, and eventually it'll figure out, like, these are the rules for it. It is not complicated at all to use it. So there is already a lot of machine learning frameworks, TensorFlow, PyTorch, scikit-learn, like quite a lot of frameworks, software that's already people have built. All you have to do is learn how to use that software. You need to do a little bit of programming to use that software. Like Python is usually the best language for this. Your all programming you're going to do is like feed the input and feed the examples to the machine learning framework. You need to define the framework as well, but it's something that can be learned. And then your machine learning system will figure out like the rules, and you save it as a file, the thing it figured out, and then it can use it. So next time it shows, it sees something that it hasn't seen before, it'll be able to recognize it. The whole act of showing it examples and then making it, showing it the correct answer is called training in machine learning terms. So that's the training of models. And what you save is a model, it's a machine learning model. So that's the model angle to this talk. And if you want to go a little bit deeper, again, it's not magic. The basic principles of machine learning, what that software does is actually quite simple. But if you look at the machine learning literature, it makes it look very fancy, and all it really is not. Because most of the literature is written for an audience that's more interested in like the mathematical proof and academic nature than for people who just want to use it. But the real principles are really simple. What ends up happening is when you have a machine learning model, what that software, what it really has is a lot of numbers, like quite a lot of numbers. What it does is when it gives it an input, it multiplies everything is bits and bytes in computers. All the input, let's say you have a picture, it's all zeros and ones, so numbers. So it multiplies that number with its internal numbers, the machine learning software's internal numbers, and it produces the output, like it multiplies, adds, and gives an output. It normalizes it and all. It gives an output, and the output will again be a number, 1 or 2 numbers. And the number, you can just say, oh, if the number is between 0 and 1, if it's 0.5 or less, it's female. In the problem that I said before, it's greater than 0.5, it's a male. And you just decide that's how it's going to be. And then initially, it's just going to give you a random output. It doesn't know anything. The software doesn't know anything. You give it a picture, it doesn't know whether it's a male or female. Just randomly multiply the input and give you back some nonsense. And you just say, no, you're wrong. This is a female. Sometimes it's, it's 50% of the time it's correct, even if it doesn't know anything. So once it makes a mistake, it kind of adjusts its numbers, its internal numbers, and say, oh, you want, I gave you a number that's 0, but you wanted a 1. So I need to adjust my internal number. So that next time, if you show me the same thing, you're very likely or more likely to get a 1 instead of a 0. So it'll adjust itself. And you keep on doing that, give many examples. Over time, it'll get good at guessing, basically. And that is actually, it's not more complicated than this. It's just that. The place where it gets complicated is doing this in a very efficient way, doing this in a way that it'll converge. It won't get crazy and go all over the place. Those are the things where you actually use a little bit of math and a little bit of computer science, and you get it more efficient. But at a very basic level, this is what it does. And what I just described is supervised learning, because you're showing it good examples and bad examples and things like that. And there are other types of machine learning as well. But if you or some of your kids want to learn machine learning, it's introduce them to it. It's not complicated. Like there's there are a lot of simple materials that people can read so that they're not intimidated, and it's really accessible. So that's about machine learning and my programming career. There is another career I have that's not programming and that's more fun, which is sports. And if I have bored you with all the computer stuff so far, this might be interesting for you. Strength sports. So I did a lot of other sports as well as a kid. Like I used to play chess in college. I was on the chess team. But this talk is about another sport I did, which is weightlifting. So again, back in 87, I was competing at the district level in Trivandrum. I used to live in Trivandrum. There is a little bit of history to this as well. So as a teenager, every boy wants to be strong and they want to have muscles and things like that. So there was an opportunity, I think a few years before this, before 87, where they were trying to recruit students to do weightlifting training. And there was an ad in the paper saying, hey, anyone can come and join our training program. This is from the University of Kerala. They had a sports department. And they were expecting about 50 kids to join this training. Age, no barrier, anyone can join. But it turns out only 5 people showed up. We had a trainer from university. He's actually a trainer of trainers. Like he's a coach, but he also trains other people in the physical education college. So he had 5 of us to train, and like we had like really dedicated time from him. He did a good job training us, and 3 of the 5 dropped off after like a few weeks. And then it was just 2 of us, me and I was in my 8th grade or 7th grade, and the other guy was from college, and he was pretty good. So he trained 2 of us for, I want to say around 2 or 3 years. Like we had a dedicated coach. It was like a big luxury back then. And the university college had a very good gym, and not many people in Toronto knows this. So I don't know if you know, like there is a stadium, university stadium in Palayam, in Trivandrum. And inside that stadium, there is an office. And on top of that office, it's a building. There is a gym in there. It's one of the best gyms in Trivandrum. Back then, I don't know. Right now, there are many gyms in there. I think that was the only gym in Trivandrum back then that had a real weightlifting bar. Weightlifting bars are very expensive. Even now, it's expensive because it needs to have that bearing so that the thing rotates. The disc rotates. It should rotate freely. Otherwise, it's very hard on your wrist if you train with a bar that doesn't rotate freely. So they had this bar up there. And this coach was like really dedicated. He really wanted us to do good. So I trained, and I was I think even people from Loyola not a lot of people know this from school. So I was the 87 district champion. And interesting thing is I was the only one competing in my age group. That's why I got the championship. So no matter what weight I lifted, as long as I could lift, I would get the championship because not many kids do weightlifting. But then I stopped weightlifting at the age, at around my 9th grade because focusing on, getting admission to engineering, and other things happened that I stopped paying attention to these kind of things. Long pause, then midlife crisis. I want to call it my midlife crisis. That kind of describes it. So I, neglected health and everything for too many years, and it was time to, get back doing something, get back in shape or strength or whatever you want to call it. And I started training. I started going to the local. There is a gym around here, I initially started training. I realized that just like you don't forget a lot of these things, even if you learned this like many years back. Just like if you learn to ride a bicycle, you're not going to forget it. Even if you haven't ridden in like 20 years, you can still get on a bike. It might be a little bit harder at first to start, but you don't really forget it. So I realized I still remembered all the lifting principles and things like that. And I also read up a lot about how to do good training and coaching and things like that. So I tried to get my son interested in weight training because he was a teenager boy. Boys usually likes to do these things. He used to go to the gym as well. So I tried to convince him to come to the gym with me. So he used to go with his friends, not with me or my wife. But it turns out like after one day or so, he decided it's not cool to be seen at the gym with dad. So he kind of refused to train with me. And so I trained alone. I used to go to the gym with my wife, and my daughter was little, but she also used to go to the gym. So wife got knew I was a little bit sad, training by myself. And this was one of those gyms, gyms where people come there, mainly use the machines. They don't go to the weight area that much. So I'm usually the only one in the weight area, like training. And sometimes one or two people might join. And the wife thought I was sad. Son didn't join. So she joined me. She said, okay, let me give it a try. What's the worst that's going to happen? And there is this phenomenon that happens when you start serious training. You see a phenomenal growth, as in phenomenal growth in strength. You get stronger like very fast. And most people don't realize this. You only get one chance to do this when you do serious strength training. The very first time you train, you should be able to, even at our age, you should be able to gain strength. Every session you go to the gym, you should be able to add some weight, a little bit more weight, a little bit more weight. And it can go on all the way to 3 months for people our age. And for kids who haven't trained before, if they do this, they can go about 6 months. 6 months is not unusual for some kid to see gains. And they will be amazed if you get somebody to do this. I've seen this, anybody that I've trained, it's super amazing to see it, because initially they come in and they may not even be able to lift the bar. The bar itself is 20 kilos, and some people can't even lift the bar to begin with. And they go back and look at it 3 months later. Is it me who did this? So it's just a natural phenomenon that happens with your body. Most people have this capability. It just, they have to be consistent. They have to kind of follow the routine, and they will see the gains. And that motivates a lot of people. to come back to the gym and do the training. But you only get one chance. It's usually explained as similar to a growth spurt that you see in kids, like kids when they grow, like they jump in growth. It's something similar to that. When you start doing serious training, you see gains, linear gain for about 3 months. When my wife was doing this, my daughter was watching this, and she was kind of amazed at what mom could do, with respect to getting strong. Like mom was super strong, and my daughter got inspired, and she started doing formal strength training with me, and she is quite strong right now. I'll talk a little bit about strength training. This is the other training. There's no age in this. Like even if our age, we can start. It's not a problem. And why strength training? It helps you avoid injuries. Like as you're growing old, you lift the wrong thing, you break your back. So being a little bit stronger, physically stronger, helps you avoid injuries especially as you grow older. And it helps a little bit with bone density as well. As you train, you also get stronger with your ligaments, and that's also important as you grow older. So it'll just make your old age a little bit more enjoyable as you get into your 80s or 90s if you're fortunate. If you get stronger. So that's why I'd say like everyone should do strength training, especially if you have kids, get them into some kind of strength training. Even if you do other sports, physical sports, strength training is known to help improve your performance in other sports as well if you're stronger. So if you have kids into sports, just encourage them to do strength training. And you have to be consistent. One of the things about gaining strength is you have to have a plan. You have to be very consistent, keep doing it. You can't just go to the gym a few weeks and not go a few other weeks. You have to go every week. Once in a while, taking a break is okay, but regularly you need to be consistent. So the way strength training works is, and this might be true with other training as well, but endurance training and things like that. But I don't know about endurance, but for strength, this works. So the principle is you put a lot of stress on your body, and then you're kind of damaging your body a little bit when you put stress, and then you rest. When you rest, you're really repairing your body. Like when you're doing strength training, it'll tear some of your muscle fibers and things like that. And you rest and you have good nutrition. Your body adapts. It's just like a tree, like a little plant. If you have, like, you've seen people do this, like you trim a little bit of some of the branches, it'll grow back with proper nutrition. So you rest and you give your body a little bit of good nutrition, and your body will adapt. And that's what happens when you train. So you have to eat clean. That is no sugar, like zero sugar. Don't go near sugar. And when you do serious training, imagine telling this to my daughter who was a teenager, like she likes sweet, like, and I said, if you are serious, don't touch sugar for the next 4 months. Like if you have a competition coming in 4 months, you got to start, clean eating. You have to do clean eating always, but especially if you're competing. The reason you do that is when you're in a competitive sport like weightlifting or powerlifting, you're categorized into weight groups. So your body weight determines who you're going to compete with. And it's important to keep your body weight. It's important to not have unnecessary body weight. Like for instance, if you eat sugar, excess sugar, it gets stored at body fat, and that body fat is not helping you when you're trying to lift something. It's just putting you in a different weight category. You're going to compete with more people with larger muscle mass, which is not good for you when you're competing. That's why you got to cut on all the sugar. You don't eat a lot of processed carbs. You get carbs from other healthy food that you eat. So clean eating is quite important to gain strength, especially if you're competing. If you're not competing, it's okay. I mean, you can eat you can put on body fat. It's not a problem. You still be stronger. But if you're competing, you need to not eat sugar, basically, and any processed food. Sleep. And again, very important for kids, especially for kids, you have to sleep 8 hours or more. 8 is the minimum, because that's the amount of time it takes for your body to kind of repair itself, so that the next day you can recover and go lift more weights.
Brain
and-
also, actually, for the
Go ahead.
brain.
Yeah. Sleeping, it's not just for, good points. Okay. We all need that. Especially kids, they don't sleep, they stay up. They stay up really late in the night, and then it's not good the next day. So women and strength training. Now, one of the concerns that I hear, especially when I try to get my daughter into weight training, even when my wife, when she joined training, like her concern was, hey, I'm going to put on a lot of muscle and I look like a man, like I won't look very good. Is that a concern? It is not. Like, building visible muscles is very hard. Like, it's not easy. You have to train for it. Like, there's a specific way to train for building muscles, like getting big muscles and good muscle definition. It's not easy to do. So you're not going to get muscles randomly if you go to the gym. Like, it's not going to happen. So that's the biggest concern with women and girls, is that, will I put on muscle? No, you won't put on visible muscles. You just go to the gym and lift weights. That's not going to happen unless you're actually training for it. And maintaining muscles is also hard. Like, once you put on a lot of muscles, as in like visible muscles, like if you don't keep training and eating clean, you're going to convert, you got to put on a lot of actual body fat. It's actually, it's very hard to maintain muscles. But when you do strength training, your muscles get stronger. It doesn't get a little bit bigger, but it's not as, you won't notice it. Like, look, this is my daughter. Like, after she has been strength training for 3 years, she just looks like a regular teenager, no muscles. You won't recognize that she actually is strong, or she goes to the gym. If you just see her, like, she just looks like a normal teenager. The only place where you notice that she's strong is in the gym. She can be a little bit intimidating to boys because she lifts a lot more than boys her age, and it's usually embarrassing for boys when she lifts, and they try to compete with her, like try to lift more than they actually can. And there's 2 occasions I had to pull out boys under the bar. They get stuck under the bar and trying to prove a point. But other than that, like, she's quite normal, and there's no muscle definition or anything like that. On the other hand, if you have kids, especially boys, if they want to kind of bring their muscles out and look muscular, it's usually a little bit of training, but it's mostly diet to get the muscle definition. You have to cut out on all the carb and sugar. It's more to do with reducing body fat to show your muscles out than actually building bigger muscles. So it's a different kind of training. That's all I had to talk about today.
I have a question.
Shajan, I think Rachana has asked a question here. How
Okay.
long should someone our age train before we see benefits and lose an inch or 2?
Yeah, that's a good question. Sorry, I haven't been looking at the chat. Okay, so if the goal is to reduce body fat content, not necessarily weight, it's very, very hard to reduce your body weight because your body has a mechanism to hold on to the body fat and body weight. So it's very hard once it's a survival mechanism, the body fat that you put in, because imagine like in the olden times when you were in farming, you have to go out and kill an animal to survive and eat, and you may not get your next meal for a week. And if you don't have body fat, you're going to die because that's your reserve, right? So your human body is built in such a way that it holds on to that fat. Once you, it's like your savings account. Once you put on fat, your body really doesn't want to give that away. And it's a good thing. It's a survival mechanism. People who don't have body fat actually have problems surviving in back those days. So only the people who survived, us, are good at storing it. So to reduce body fat, if that's the goal, it is. It's usually diet, it's not exercise. So exercise is good for your mental health and generally like mobility and things like that. But to reduce body fat, the most effective way I've seen, like when training athletes, is don't eat any sugar. Like it's very hard to, it's very easy to say, but it's very hard to do. Like try to reduce sugar from your diet. Like sometimes it's not sugar that you put in your coffee or tea, like that you have control on, you can change it. But it's usually when you eat outside, a lot of food that you eat, they have sugar in it, even though you don't realize it.
Does these baked food, most of them, right? I mean, I don't know whether that has got a lot more sugar content.
Yeah, it's
Right?
very
Baked
surprising.
foods also. Hmm.
I think there are other people in this in our CET class who are good at nutrition. They might have better advice than me, but what I would say is don't eat any sugar if you can help it. Reduce your carb intake. Some people say calorie, you have to count your calorie. I don't believe in it because not all calories are equal. Like for instance, if you're eating protein, that usually is digested a lot differently than when you're eating pure sugar or pure carbs.
Yeah.
So they have the same calorie, but they have a different effect in how it's converted into body fat. Yeah, and if you're eating, you have that craving, just eat it with a little bit of fat. Any food with fat is actually good for you. So that helps slow down the conversion of sugar into stored fat. So it goes to the liver and then it later gets to the stored as fat. So maybe somebody else might be able to describe this better than I can, but TLDR, the summary is that it's the diet. Like if you can figure out a way to have a diet that's low on sugar, that usually goes a long way. But again, it's your body is really smart. It's going to fight you. It's going to try to hold on to the savings it has. So, that's naturally how it is. And, it's not a bad thing to have body fat. It's actually a survival mechanism. It's a good thing.
Shajan, you've been very super modest. This is not going to help people who have all assembled here. We need data. So, like you are the national coach of the US team. You have to just tell us tangibly at least what actually happened. We really don't know. So how you have competed, how your daughter has competed, who all have you coached? So
yeah. So my daughter has been on the US national team for I think 3 years now. She has been competing internationally, and
Nan,
she,
you have any
and
questions?
how much does she lift?
No? On machine learning? Nothing.
yeah, depends on the lift. Like she can lift 100 kilos. It's about I want to say about twice her body weight. And as far as me, I've been a national coach from around the same time my daughter got into the national team. I continued to I have to renew it every year. So yeah, I'm on the US national team as a coach and a sub-junior women's coach. So I do talk to a few athletes, but I don't officially coach because there's a lot of liability if they get injured. Like I get into trouble, it's very hard to get insurance for me. So it's a big expense if I do commercially do coaching. But I'm a certified coach, strength coach, also on the national team. That's about it. Like if you have teenagers or even yourself, if you need ideas on how to train, how to gain strength, I can help with that.
Be great.
Shajan, You had to take the certification because you had to coach your daughter. Is it like that, or you had to?
No, for my daughter, I didn't have to take certification. I had to take the certification to be on the national team. So when you're on a national team, of course, you need to know how to do strength training, but there's also a lot of legal things you need to know how to do, drug testing rules, the official competing rules, all the women's team, like if you're coaching women, like there's certain men as well, like there are certain things you have to know, and quite a few things outside of strength training also you need to know. There's a lot of ethics training as well.
Also on the weight training, I just have one query because my son actually is aspiring to be football, but then main issue is that he doesn't want to take non-vegetarian. So I always have difficulty when I take him to the gym to continue with the food cuisine. So
yeah, so what he needs is protein, and protein comes from not just meat. If he eats meat, that's easier. If he eats egg, that's also easier. But if nothing, like he can have a lot of milk. Milk is one of the main sources of protein. He needs to drink a lot, like a gallon a day kind of thing, if he wants to gain strength. The other option is whey. There's a protein called whey protein you can buy. Whey, it's milk based.
Yeah, okay.
Yeah, it's actually milk. Milk's protein is converted into a powder form. That's what most people who do strength training complement. If they can't eat enough, they take whey protein. It's actually milk protein. They don't mix anything. Yeah, when you buy whey protein, like people mix sugar and things to whey, just buy the pure whey. Yeah.
Okay. Thank you.
Shajan,
has a question. Oh.
Shajan, do you remember any arm wrestling things that we had in our rich batch?
Yeah, I do recall I was into arm wrestling quite a bit back in college. Do you remember that? Well, did I lose to you?
No, you were too.
You're muted, Sujit. You're muted.
You were too modest, and as you normally are, you are too modest, and nobody knew about that, and a lot of people had a tough time. I remember that.
Cool.
Yeah, Raji, please.
Yeah, this is a question from both of us. First of all, Shajan, thank you for sharing the background. It's such a shame that we didn't know you had such a ton of experience with programming, and you were way ahead of probably most of us in the CS class. So that was an eye-opening background on you. And quite surprising and exciting to see that you took strength training and training your your daughter seriously, and you pursued it with discipline and whatever certifications needed. We are all struggling at that age where we're trying to figure out how to maintain and manage our body weight. The scales remain the same, but the inches seem to add on. So what's your thought on two topics? One is intermittent fasting, and the second is the high intensity interval training. There's a lot of buzz around that, and I get confused and confusing responses. So would love to hear what your experience has been.
Yeah, I think that's a great question. It's quite relevant, both intermittent fasting and HIIT or high intensity training. The thing about high intensity training is you want to make sure your doctor is okay with it. You don't have any other medical conditions because it reduces what it called ATP. Or so when you do a heavy lift or very high intensity thing, your blood has your system has something called ATP, which kind of gives you the energy to do things. Once you drain the ATP, it can drain really quickly. When you do high intensity things, you may get dizzy and fall down and get injured. So make sure like you're in a good state of health if you do high intensity training. It has results, like it'll help burn a lot of calories so that you don't so it's still not sufficient. It'll burn calories that you eat, but it's not going to touch your fat that's stored. Like it will, like only if you starve yourself to do it, but then you won't be able to train as hard as before if you keep on starving. Intermittent fasting, on the other hand, is more beneficial, I think, at least in my opinion, because what it does is, as your body is quite smart, like it has this control system in it where it won't get rid of your, like if you have stored fat, it won't give it up that easily. The only thing that seems to be effective is intermittent fasting. What it does is, it forces your body to go into a different state. Like your regular operation, you eat, you use it for energy, you have nothing to store, you store a little bit in your liver, and then you kind of release it and you keep using it throughout your day. But when you do fasting, what happens is after a certain amount of time, like 16 hours of fasting or so, your body goes into a different mode where it knows, okay, something is up. My normal operating procedure is not working. So it sits into a different mode where it starts kind of drawing on some of the savings account. And it may use a little bit of fat. It's quite stingy. It's not going to use a lot, but it's going to use a little bit like that. And that starts only when you are fasting. It depends on the person, like usually 16 hours or more. What I recommend is something to try out is fast for a whole day. Just pick one day a week. Doesn't matter what day, like that works with your lifestyle. Fast a whole day and do that consistently every week. It has to be a lifestyle. And then eat normally, like, on the regular other days, just eat normally. That fasting actually seems to help. It gets a head start on burning that stored fat, if that's a goal. It's also quite healthy mentally, and you feel a lot better the next day. I did a few of those, and it feels really good after you have fasted. So if you cannot do that, intermittent fasting is good. 16 hours a day, fast every day. That's also good. But again, it's a lifestyle change. Your whole family have to be in it. It's hard, but I'd highly recommend it if you can do it.
Okay, thank you.
When you're
Shajan.
really fast, you're on liquid diet or nothing at all?
When you're fasting, you can drink water. Water is fine, but don't. Tea is okay, but don't put milk in it. Try not to consume anything other than these.
Bindu, you want to go ahead?
Yes. Yes, Wahid. Thank you. Hi, Shajan. Yeah, it was a very nice, interesting session, because after a long time, I'm joining this session. I could recollect what I also did in the engineering college when you told about Fourier transform and all those things. So it was nice. So my question is, so thank you for that, and explaining machine learning in layman terms. That was also very good. So I have a question. The reason is you told of whey protein can be taken, right, as a supplement for vegetarians. But the one for me, I had a bad experience here. One of my friends here, one girl, she's very young girl. She's of around 25 years. She was trying to put down her weight, and she's a vegetarian, and she took this protein supplement. And after 6 months, she started getting stomach pain. And here I'm in Ireland, okay? So she went to the doctor here. They gave her this painkillers for 1 month. Somehow she was feeling better. But off late, when she went to India and did a scan, she found that her gallbladder was full of stones. And the reason was this protein food. So this is what the doctor told, and they had to remove the gallbladder. So now she's without gallbladder. So yeah, so this is a live example which I got to know recently. So what do you say about that? Do you have any experience in that?
Yeah. So if you're, so too much protein is also bad for your body. Like you need to. There is the recommendation is for protein, like just one. So it comes with a measurement, like it's
actually she was undergoing this training with a gym trainer here, because they have nutritionist, they have gym trainer. So all this she was following. But even after that, she ended up in this.
Yeah, it's always, yeah, there is always risk in if you consume anything that's not natural, like there is always a risk. And it's always
And
a
is
good
it
thing to,
water? Do we have to drink a lot of water or something like that?
yeah. So if you're training, you really need to drink water so that you don't dehydrate. So and even if you're not training, water is usually good. But anything that you do, you anything new that you do, you haven't done before, including training. Let's say you didn't take any whey protein or anything like that. Consult with your doctor. Just make sure your physician is okay with you doing all those things. But sometimes there are medical conditions that remains undiagnosed, and you doing very intense training can bring things forward. So it's always a good idea to talk to your doctor before doing anything new, including training or getting on a diet like intermittent fasting, full fasting. Anything new you do, I'd always encourage people to just have a conversation with your doctor before you do that, and after you start doing it, do tests to make sure nothing has gone wrong. It's unfortunate.
Yeah, okay. The problem is here we don't have access to the doctor itself, right? So to get a GP appointment, we have to wait and wait even until we die. So
That's
we can't go
unfortunate.
for such things. Yeah. So it's better to go to India and do some consultation.
Shajan, moving on to this.
Okay. Thank you. Bye.
Thanks.
Good question.
Yeah, Shajan, again, going back to your career. Okay, again, you've been there very skeletal in telling us exactly, so you work with young engineers, you still code. How is that you are, all 30 years you're the only coder, or in Twitter, or you are the one who writes all the code? So how is it? How many engineers are coding Twitter?
Yeah, engineers my age still coding are rare, but there are still people like me. We have old people coders group and things like that. Yeah, there are fewer and fewer of us coding at this age, or at, with this level of experience. But there are a few of us. We usually work with young engineers. And it's fun. It makes us believe we are also young working with youngsters, and it's amazing. I'm not just saying this for the sake of it. These kids are very smart. Like they keep getting smarter for some reason, or we are getting dumber. I don't know. They come up with these ideas that you haven't really thought about, and you're amazed. Like, the kid just came out of college, worked a year, and he or she is coming up with this idea that you've been in the industry 36 years and you couldn't think of it. And this kid just comes in and says, hey, why don't you do it this way? And you realize they're right. And you've been, you haven't even thought about it. And this kid is thinking at this level. So they usually, it's very fun working with youngsters because they're not constrained. They haven't been burned like you were. And it's like you are burned before, thinking about it this way, and you don't even think that way. But the fresh mind comes in, they're not constrained. They're going to push you in different directions. And it's always fun to work with less experienced programmers and engineers, and they have a lot of good ideas, and
so you're the senior most. You're the senior most guy there. So pretty much everything in Twitter you decide, I think.
No, not like that. So yeah, it certainly, like, we have senior engineers who get to review a lot of things, but we don't get to decide. No.
Somebody senior to you? Maybe older.
Older, yeah. There are a few people. We don't discuss actual age. Once you get to about 40, we don't. That's a place we don't go to. But yeah, I might be one of the oldest there, still programming. Yeah.
Sorry, I want to say something. Go ahead, Shajan.
Go ahead. I was done.
All right. So within Twitter, Parag's appointment, did it come as a surprise, or was he groomed for that role, or was he being groomed for that role?
Parag has an interesting career path. I don't know if he was groomed for this role. Like he used to work very closely with the CEO, then CEO Jack Dorsey. One of the good things about Parag is that he understands. He started as an engineer. He understands the ground truth, like what can be done, what's practical, what cannot be done, versus Dorsey was a little disengaged. He started as an engineer as well. He founded the company, then he went off and then came back. He was a CEO for 2 companies, and he was hardly spending any time at Twitter. So Parag, I don't know if he was groomed for the role, but he is. He definitely have his strength with respect to taking the company forward. So he's still like learning in his role. But he has a lot of support from at least the engineering folks in the company. I think he's going to do a great job.
Great, thanks.
Edward.
Thanks, Wahid. Shajan, good to see you. After a while, I was able to join only during the later part of the meeting. So I have a few questions on the exercise part. Okay. Before that, I totally empathize with you on, staying with programming, choosing to be in the programming line, because it's something that you love to do. And, unfortunately, in many companies, the role you take, after a while, it forces you to take a lead role or a management role. And then you end up doing something that is not your cup of tea. And then, it gets complicated. But I always appreciate somebody who sticks on to what they are good at, and they can enjoy all their life. Every day they get to enjoy what they do. So, that's a good thing. I'm glad to hear you did follow that route. Now, coming to the question part on the exercise, now that we are all nearing our 50s, whatever little muscle mass that we have, how do we maintain that? What is your thought on that? I'm sure the rate at which we lose our muscle mass is much higher than what we used to do 10 years or 15 years before. So that's one question I have. Second thing is about the body fat. All of us, most of us, I'm sure would agree with me. Even if we do exercise in whatever frequency we are comfortable doing and dieting together, there are some part of your body you are able to do or build the way you want. But then there will always be some part of the body, example, it could be your thighs or your belly fat, that will always stay there no matter what you do. It will be there. And so when you look at yourself, okay, you've improved in certain areas, but then you are always stuck with certain areas that you are not able to improve beyond a point. So these two are my questions. One is regarding how to maintain your fat, muscle mass at this age. That is my first question. Second thing is, at a targeted area, be it your belly or your thigh or whatever, is there a possibility to remove that fat, even to some extent? I know you cannot be a model, but even to some extent, better than what normally people achieve.
Yeah. Let me break this down. So as far as muscle mass is concerned, just like your body doesn't want to get rid of stored fat, it's very hard to, once you build a muscle mass, it's very hard to lose the muscle mass itself. So the body won't digest, it'll use muscle, it'll break down muscle for energy, but only after it has exhausted all the body fat in your body. So you don't have to be worried too much about losing muscle mass, unless you're into your 80s or 90s. That's when muscle atrophy happens and your body starts digesting muscles once it's done with all the fat. On the other hand, if you want to build more muscles, you need a lot more testosterone, which, as females have less of, males have more of as a hormone. And as you grow older, like once you're past your 20s or mid 20s, you don't generate as much testosterone as you used to. So it's very hard for people about 25, 30 to actually gain muscle naturally, increase muscle mass naturally. So instead what happens is you hold on to your muscles, whatever you gain, it's hard to lose it once you gain it. That doesn't mean you'll get bulky muscles or anything. Whatever fibers you have, you're going to retain it for a very long time. It's also a healthy thing because these muscles are not free, like it needs to be fed. So you burn more calories if you organically have a lot more muscle. So you need to eat more to, your body, more you eat, your muscle is going to consume a lot of it, the more muscle mass you have. So I wouldn't worry too much about losing your muscle mass once you get old, unless you're in your 80s or 90s, when body naturally dissolves it. The second part is targeted reduction of, let's say, your belly fat or any particular area. I don't know there is a way to do it. People claim there is, but I'm not really convinced there is actually a way to target a particular area of your body to lose muscles. Generally, what happens is your body, when it's starving, it's going to consume fat. And depending on whether you're a woman or a man or certain body types, certain areas are preferred to, when it consumes, it kind of has some preference on which fat to use for energy. And once that is done, it goes to the other area. And when that is done, it goes to another area. So that's why you see some people when they starve or when they try to cut fat, they eat less, but they look terrible because they have fat, but only on their belly, but they lost all of them. They look worse actually if they lose fat. And it's just, that just happens to be the way the body works. And, I don't think you can just say like, hey, I want to reduce fat on just my belly, just my leg or anything like it. It doesn't work that way. At least that's my understanding. You should probably like check with, that's my understanding.
Yeah, thank you, Shajan.
Yes, Smita.
Shajan, are you involved in recruiting at Twitter also? You were talking about those young, bright guys. So what do you look for? If you're involved, what do you look for to select such people? Because you're going to get the cream of cream, right?
Yeah. So what I look for during recruiting, like I'm on the interview panels. I'm on like, I usually recruit senior candidates. I have very little say in fresh graduates because I'm not on that. I am on the panel that determines the rubric or criteria for it. So when I'm creating rubrics, what I usually say is hire for potential, not for what they know right now. Like, look for their potential. It's very hard to tell when they're fresh out of college, how good they're going to be. So you take a chance, you hire them as long as they can code, they understand CS basic stuff, you think they're going to be effective, just give them a chance, hire them and see how it goes. The people who are successful, on the other hand, what I notice is that there are two types of engineers that I see, at least in the industry I'm on. One is people who are really good technically, like depth-wise, like you give them a problem, they will take time, but they'll come back with a very good solution. They will have looked at all the other things and very thorough. That's very valuable in some situations. Some situations it can be a liability, where the other types come in, where they're just, you tell them something, they'll run with it. They will create something, even if it breaks down like 6 months from now, they will get it working. So that's useful in some other situations. You have both these extremes, both are valuable when it comes to junior engineers. When it gets to a little bit more senior, what matters more is communication than your technical skills. So you should be able to explain your thoughts to other people because you're not working alone. So communication becomes a very important skill to have once they go past their first few years. So if you are looking for how to ace some of those technical interviews, there's something called LEET code, LEETCODE. Just look it up. It'll help you pass the interviews, the technical interviews.
Smita is on the panel that determines how future skills has to be trained in India. So
Oh,
she
wow.
is trying to find the solutions for the HR problem in India from NASCOM perspective. So that's the
Nice.
question. So
Yeah, that is the
resource.
background.
Yeah,
I'm gonna bug you more, Shajan. This is just a starting.
He has almost retired now. He's given up on Wipro and now on trying to help the struggling IT industry to find out the right recruiting and skilling mechanism. So Shajan,
Wow.
your insights will be very useful.
Cool.
Yes, sir.
Hi, Shajan. Sorry, bit throaty. I'm COVID positive at the moment. So sorry for that.
This is number 4.
Wow.
With 3. Welcome to the club.
Yeah, thank you. So yeah, thanks. Seeing you again after, what was it? I think I left you in the reunion place over there. Probably I offered you vodka or something and I went off and then never came back. So I have a vodka which I should offer you at some point. But yeah, no, a great session. No, I was not expecting to have like a fitness and weight training session from you. No surprise. You always, to me, you always like an iceberg. No, very cool, calm, but there is a lot more under the surface. Always to offer, so amazing. So I think we were together in Evanius and C batch, isn't it? C batch, and yeah, great. I know that my question was again coming back to fitness sort of thing. No, നമ്മളെല്ലാരും കുറെ trying to improve body tone and all those things. Is it okay to do some sort of like people who are not used to a gym and all, like home fitness? What can you do? Can you do like dumbbells and some stuff before you go to a gym, or can you go straight to a gym?
Yeah, you don't have to prepare for going to the gym. I mean, that's not a necessary step, but if you have to, it depends on what your goal is. Like if it's strength training, like I'd say like doing, even if you don't have access to gym, you can do push-ups, pull-ups. Pull-ups are really good. If you can do pull-ups. Again, the one constraint that you'll have at home is you won't be able to overload. You can increase the number of repetitions, but you cannot increase the intensity. So that's one thing you will miss if you don't go to the gym. But doing push-ups, doing pull-ups, other cardio activities are good enough. You don't necessarily have to go to the gym. But again, it's not a prerequisite. You can just directly go to the gym if that's what you want to do.
Okay, great. Yeah, good to see that you also had a Spectrum. I had a Spectrum Plus.
Oh wow! Okay, yeah.
I think I still have it at home.
Wow. Very nice.
Thanks.
So you had the same struggles I did with tapes and all. Okay.
Shajan, you've seen technology, evolve from 1990 up till now. So can you just give us in layman terms what is going to happen? AI, MI, what is your feel where the technology is moving, how we should be, how is there any reskilling required for us, or we have to start early retirement?
Vahid, you just took the question from my mouth.
Yeah, I don't know. These things are very hard to predict till you actually are in it. Like a few things that I've seen promising is machine learning, and that area is even maturing more even as we speak. There are new research coming out, and that whole thing is I think it has many more years of growth coming up. Many new things will be done more efficiently, more automation. Self-driving car is a reality now. It's not like just a researchy thing right now. It's not perfect, but it's safer than humans driving the cars, for instance, at least in my opinion. And all the data shows that as well. So things like that are going to be very very much happening. The other trend that I'm seeing, which is actually it's not very publicized, is the Web 3.0 thing with all the blockchain. It's decentralization is also like happening, and I think it's also going to make an impact. So one way to look at Web 3.0 is, today if you want to create, you as a consumer want to create, use a website, you have to sign up, you have to provide your credentials. And I think that's broken. Like, you don't necessarily have to do that. You can create your own credentials, just like a crypto wallet or something like that. So those things are going to happen, where things get more decentralized. You don't have to depend on big companies like, I'm sorry, met somebody from Meta here as well, like Facebook or Twitter, even Twitter. Why should they all have your data? Like there might be a better way to do this. So that might happen as well. I don't know. Yeah, if I had I'm not good at guessing what's going to happen next. Unfortunately, it's too many possibilities.
But Shajan, just a thought. I don't know if you have a different opinion. I would love to hear. In the last 2 decades, we are seeing more and more automation, as you rightly said. More things are happening. I mean, there's more plug and play type of software that is coming in. Then the level of knowledge, technical knowledge that you need to know in computer science for a layman is decreasing, because more and more stuff is already built, and it can be plugged anywhere in whatever application or need that you have. So if this trend continues, obviously, things will become more efficient. The need of the people will be met more efficiently. That is definitely going to happen. One of the examples that you said is self-driving cars, which I believe is a great achievement. But then I feel that for the future computer science, new undergrads or new pass outs, they don't have much work to do there, because more and more things are already built, and machine learning or artificial intelligence is taking up things. So I believe that there will be less opportunity for programming, less opportunity for computer-based work as we used to do 1 decade or 2 decades before. That's my hunch. What is your thought on that?
Yeah, that's actually a good point, and in that a lot of problems are getting solved, and things are easier and easier. You don't need a lot of skills to get things done. But the one thing that's still open is, if you look at the research, the area of research in CS, there's a lot of open problems still, quite a few more than when we all started. So on the science field, so if you're getting into the academics, and if you're getting into the science and that part of the industry, there's still a lot of growth there. Like, there's still things happening. A lot of money gets into research, both in universities as well as in companies, like large companies like Google, Microsoft. They all spend a lot of money on research because there are a lot of open problems that's not solved yet. But when you go down the path there, when it gets to getting things done, as creating software, you're right. Like, it's a lot easier now that things are there. You just need to put things together. To put things together, you don't need a lot of skill. You still need that skill, but not a lot of programming skills, kind of thing. So yeah, so the demand for that is going to keep going down. But there is also the demand of creating those components that other people use to put things together. At least my view is that we still have demand, like, as in, like, there's still a lot of demand for CS skills. But deep CS skills, you're right. Like, many of the things we learn in college, it's not, there's just very few companies where you can actually apply those skills that you learned. And that is a reality. but I'm optimistic. Like even my daughter, like she's going to take CS. I don't think it's that bad. I think there's still growth. It's not as big as it was.
Okay. Yeah. So let's hope that there'll be more, challenges that will come up in the future on the computer science front.
That's my hope as well.
Shajan, I've heard that, the way you used to think for programming and the way you think for AI or ML is totally different. And therefore, when people have a framework of programming and background of programming, for them to switch into machine learning and AI is a bit difficult. You've worked in both areas. What is your experience, and how is that, how is it possible to transition? How will you bring the past and the present new way of progressing of computer science together?
Yeah, so people, at least our generation, like we still had access to machine learning, like when we were in college. Like I remember one of our colleagues' thesis was on machine learning, training a model to recognize handwritten digits. So it was there even before. It just wasn't that popular or that useful. So one of the things that happened is when we all graduated, since the machine learning ecosystem hasn't grown that much, most of us didn't pay attention to machine learning, just went the traditional non-machine learning route. And now, especially people of our generation, now we have to relearn machine learning because we just neglected it. But if you look at like students passing, getting out of college recently, they're already familiar with this thing and they already can use machine learning if they put in a little bit more effort in it. So depending on the generation, the transition might be harder. Like for instance, if some people are not, they're just used to specializing in something, and if something new comes up, they find it very difficult to move. For those, it's going to be hard. But if people who are recent graduates haven't been in the industry too long, it's just going to be another tool they have to learn. That transition, I haven't seen it to be bad or difficult per se. It's just another tool, just another thing that that you have to use and learn how to use. I'll say one thing though, we don't emphasize teaching statistics when we were in undergrad, like in CS. I don't think we even had a statistics class in CS back when we did our engineering. So if you have CS graduates coming out with no background in statistics or general math, they'll struggle to get into. To use machine learning, you don't need to know any of these things. You can use machine learning to solve a problem without knowing statistics or any of those things. But if you are into improving machine learning or doing research in machine learning, then you have to be good with math and statistics. So different, it depends on what you're trying to do and how flexible you are. Yeah, so it could be difficult for some. It could be easier for especially the newer generation.
What about the domain knowledge? I think that's also to some extent required, right?
Yeah. So yeah.
It's a mix of.
When you say domain knowledge, do you mean the industry that you're trying to solve a problem in, or domain of computer science? Okay.
No, the industry you're trying to, or the business scenario.
Definitely. If you want to apply machine learning for anything, you need to either know the domain that you're applying this to, or have access to somebody who has the domain knowledge that you can use. Yes.
On a basic question on machine learning, between TensorFlow and PyTorch, which one do you use mostly?
This is a religious argument, but so we use TensorFlow at Twitter almost exclusively. But if you use the Facebook people, they'll say PyTorch. So it depends. Like in the industry, I'll describe this in a neutral way. The industry prefers TensorFlow because it's more robust for the production kind of scale usage, and the researchers prefer PyTorch because it's more more flexible. You can try a lot of researchy things on PyTorch. You can do that in TensorFlow, but it's just harder. So the research community usually almost publishes papers with examples in PyTorch, versus when you get to the industry, it's more biased towards TensorFlow just because of performance reasons. For instance, the services that I kind of build, we do about 60 million requests per second. And it's like 20% of our whole data center footprint just doing this machine learning. So this has to be very efficient. A little bit of slowdown is going to cost the company millions of dollars per month. So every little bit of performance is important. And PyTorch doesn't scale. Sorry, like PyTorch fans, it's slow. It doesn't work for us. So that's why industry tends to go with TensorFlow. I'm not saying like PyTorch won't work. It just, we don't want to be the first one to go in and find all the problems and fix things. We don't want to spend resources on that. We just go the easy path, which is TensorFlow.
Okay, thank you.
Shajan, again, the question on the machine learning side, and I'm no expert in machine learning. I basically try to apply my common sense and see where things are going. So in a typical machine learning context, when I look at it as a system that interprets the data around that and infers that meaningful data, meaningful information, and transfers that into some output that is useful. So that inference, smart inference, that's where all the intelligence part is. Can ever these systems be creative or innovative? Because if you know what I'm asking, you can program a system in such a way that, okay, these are the different hundreds of data points that can probably come into the system. And then you can work on the ways to interpret that data smartly. That is one thing. Being creative is a whole different level. Being innovative is a different level. Can ever computer science get to that level? This is a question out of curiosity. You being in that line of work.
Yeah, this is a better question for someone on the academy, and maybe Darshana is here. But I'll give you my opinion as an engineer, not as a researcher. At the basic level, what machine learning does is it's trying to guess, and when you're guessing, sometimes you can make creative guesses, but generally it's not creative. It's just you're creating a system to find the patterns, and you kind of follow the pattern, try to generalize. That's what there is another field of machine learning that's generative adversarial networks and things like that, where you can create music. You actually can today train a network to, you give it a lot of sample music and it'll create new music for you. And it's not a theoretical one, it'll do it. But again, like, it's not really being creative. It's, it's kind of changing things a little bit here and there, and then creating things. Like, similarly, you can create faces that it'll look like it'll be trained using a lot of human faces, and it'll generate another human face, which will not be any real human, but it'll look like a human. So I don't know if that can be called creative. But to an engineer like me, it looks like it's another engineering thing. It's not being creative. So it also like has what is creative. And I'll give you one more example where there is a way of training called RL. And the way the RL algorithm works is it simulates an environment, makes changes, and see if it's making a better change, and it gets better at making changes. Over time, it gets really smart. This is how the best chess thing works, chess training works. Previously, like, they used to show a lot of examples of games, and then the chess training machine learning model kind of learns from all the games that has played so far, and it gets very good at it. But there is a new way of training a reinforcement. That's what RL stands for, where it simulates, it actually makes dumb moves initially, and then it figures out, oh, that was a dumb move. And it does like a billions of moves, and it learns itself. It doesn't depend on learning from human history. The advantage of that is these algorithms are much stronger because it can think beyond what humans have taught so far. So those are better at playing chess than the traditional way of training chess bots. I don't know if Darsana, you had a comment on creativity. I as an engineer, it's all like made up. There's nothing creative here. Or anyone from the academia or
Monali will have comments.
Okay.
ഞാൻ ഒരു ക്വസ്റ്റ്യൻ ഇട്ടിട്ടുണ്ട് ഗ്രൂപ്പിൽ.
Oh,
വാട്ട് ഈസ് ദ
yeah.
ഡെഫിനിഷൻ ഓഫ് ക്രിയേറ്റിവിറ്റി എന്നും പറഞ്ഞ്. അതൊരു വലിയ ലോങ് ഡിസ്കഷൻ ആണ്. സോ ലെറ്റ് us keep the focus on you.
Spoken like a professor.
Okay, Shajan, I have another question. What is the hardware, requirement for hardware for this machine learning?
So at least I can speak to Twitter. Like we have different machine learning situations. Some have to do with classifying videos or images. It has very different requirements than let's say figuring out how a user embedding kind of representation of a user or a tweet or language processing. That's different. So the thing, what we do is instead of buying hardware ourselves, we use the cloud. We use Google GCP, and there you can select the hardware that you want to use. Like for instance, we use GPUs, certain types of GPUs, A100s, things like that. And sometimes we haven't started using TPUs, that's tensor processing unit that Google sells in their cloud. So you can rent it and use it. Basically, what you're trying to achieve is the lowest dollar amount you spend for the amount of training you want to do. And sometimes it's latency sensitive. Like some of our training used to run like for weeks at a time, but that's too slow. So you want to pay more money so that you can train it within a day or a reasonable amount of time. So you have to figure out what's important for you, like reducing cost or getting more training done, or get the training done in a shorter amount of time. And you can come up with different equations. We even do some training in CPU, not even GPU, because it's cheap and it's cheaper and we don't need it that fast. So it really depends.
Okay, fine, thank you. And do you have any contacts with Twitter Ireland, R&D center here?
I don't. Yeah, I don't know of anyone there. Sorry.
Because I know I just was just checking. I don't want to work. I'm not planning to work. But my husband, he has done the course on ML recently, software engineering with this ML. So that's why I asked this question. And
certainly have him reach out to me, like sdasan@twitter.com if he has questions.
Yeah, sure. And one more thing, you in the beginning, I missed some portion. You were telling that if somebody is there with town planning experience, they can join some company. What was that?
That's my son who took urban planning as his major, and now he's in his final year, and he's trying to for a job. And what I'm realizing is that there's not enough jobs in urban planning, and he took a course. Yeah, that's his passion.
Shajan is very smart. He started the session with that.
So your son is looking for a job.
Yeah, he's passing out this year and he's looking for a job. And I realized like he took a course that, there's hardly any job.
Because I have one girl here. She's working for Chennai company from here. And she is looking for a job here and in US. But she's not here. There are a lot of opportunities in Ireland, but she couldn't clear the interviews till now. So maybe I can check if some remote working is available.
Yeah, thank you so much. Do connect us. Appreciate that.
Yeah.
Shajan, I have a question for you.
Thank you.
This is regarding the other side of your life. So what is your schedule like like മോളുടെ കൂടെ when you go for like a competition, for example, how is it like yeah, just take us through a day or a couple of days when you go through a competition.
Yeah, so work-wise, it's not a hard for me because again, like I stay away from management and all those things. I'm still an individual contributor, so I just plan ahead. Like usually when there is a competition, we know the dates and the venue 4 to 6 months ahead of it happening, so I can plan my work around it. So we usually travel, we fly in if it's a remote location at least 2 days before the competition, especially if it's in a different time zone, so that the athlete gets used to the new rhythm. We get to the place, we make sure we have good access to food. It's a funny story. Like when the food story is funny because we are very picky on what the athlete eats. During training, you don't want to get to the competition and realize that you're overweight. Then you get disqualified. You cannot compete because you qualified for that particular weight. So you got to keep your weight in check. So usually when we book the hotel, usually the competition, they recommend these hotels to go, book your reservation. They usually have a weighing scale in the hotel because of the competition. So we keep checking the weight. We go in, fly in, relax for the 2 days before competition. Maybe the first day we may go in and usually they arrange a gym or something and do very light workout. And then do the registration. There's usually an ID check and all those things. And on the day of competition, they have to check your weight and your athlete's weight, identity, and they may do a random drug test as well to see if the athlete has been using any illegal drugs. And then you go to the competition. You usually you don't eat anything till you weigh in. Like usually the weighing is in the morning of the competition, so you kind of starve and you go to the bathroom and all before weighing in, and then you weigh in and then you eat. The athlete, not me, the athlete eats, relaxes, and then warm up, and then the competition. We get to go around the city, or if it's a new place, we spend a little bit time exploring the cities and all. It's a very fun experience going to competition. Usually me and my wife also joins us to everywhere she goes. My daughter goes. One good thing about drug testing is, especially if you have teens, they know they'll get caught if they use pot or anything like that. It'll stay in their blood. And it's not just during competition they get tested. We have this in the US where if you're on a national team, you get random drug testing. So they can call you up anytime and they'll give you 1 hour notice, and you have to, there's a website you got to register and say, I'll be at this location. If you're traveling to a different state or something, you have to say like, these dates you're not going to be available for drug testing. So they call you up, they give you a surprise visit with the drug testing kit. And if you fail, you're banned from any national events for 4 years. So kids take this very seriously. And if you fail to appear for the drug test when they call you 2 times in a row, you're again disqualified. So it's a pretty serious thing for kids. It's a good thing for kids because they, that's an incentive for them to stay out of drugs and stuff.
Oh, thank you. So that must be true for every athlete in the national team. So like the recent basketball player, so there was perhaps no way she could have had it, I guess.
I didn't see the news on that.
No. I'm talking about the basketball player, or the Russia, or the woman who was
skating. There's figure skating, I believe. Right?
Oh. Yeah. Okay, so Russia is known to, Russian athletes actually have a very bad reputation with drugging. So even in our field, the weight strength athletes, Russia got banned, I think, last year from competing because of this problem. No matter how much people say this, they still try to cheat. Like they use they use chemicals. Like what that allows athletes to do is so right now, like we can only train like 3 to 4 days a week because that's how much time it takes for the body to naturally recover. So some of these athletes, what they do is they inject stuff that helps speed up the recovery. So they can try, instead of training 4 days a week, they might be able to train 5 days a week. That gives them a real advantage when it gets to competing in strength sports. The only way to catch this is if you do random testing, because they'll be clean for 4 months before competition, but the year before they might have been using, drugs, and it's very hard to catch them unless their country is testing them thoroughly, just like the US does. India also does good drug testing. I know people who actually do the testing. It's a big problem because the problem with the drugs is that it's a very long-term effect is bad on athletes. But again, the athletes who are really interested in this have to do it if everybody else is doing it. So that's why, like the International Olympic Committee, they are all like very strict on drug testing. If they doubt something, they'll disqualify the. There's a process for appeal and all, but quite strict. I don't know what news you're referring to, but yeah.
Shajan, thank you very much for it's almost 2 hours. We are all sitting quite attentive, very valuable, inputs that you have given. I would like to open for any more questions before we close.
I have just one online mentoring possible, Shajan.
For weightlifting or machine learning?
Strength training as well as on the computer.
I do have a class that I sometimes take online. It goes for 6 months, 1 day a week. So yeah, if you have someone interested in it, I'm happy to set some class up, definitely. For training, strength training, it's very hard to do online. Like you have to be there. Yeah, you don't want kids dropping weight on their head. Nobody there to catch it.
I mean, the tips and tricks, maybe not exactly the things, but at least some regime or something to abide by. With a supervision will happen in the gym where they're going, but at least some do's or do's and don'ts, whatever.
Yeah, happy to do that if you have someone that you recommend. Like I can spend time with kids. Yeah, definitely.
Thank you.
Shajan, as closing remarks, if you can say, is there, you talked about model training and training athletes. Is there any similarity, or are you doing it to balance both the trainings to ensure that you remain sane?
Cool. Yeah. First of all, thanks everyone for attending and being patient. Very good quality questions. Thank you so much. I know it's late for some of you and very early in the day for others. Thank you so much for being patient, listening. As far as Wahid, to your question, training athletes are way harder than training machine learning models. Machine learning models are easier to train, but athletes are real human beings with a control system in themselves that kind of goes against what you're trying to do. It's quite hard to train humans.
Sure.
Thank you all.
Thank you very much, and Shajan, thank you for a very good session, and that too done in short notice. We know you are always there for us, and I wish each one of us know him more. I'm very lucky to be that one of those people who know him a little bit closer. So we all have to work together and collaborate to actually probably create a machine model out of ourselves.
Hopefully.
Okay, thank you and good night. Next week we'll have Jayasree. Please, these sessions are more listening sessions, at least. So we have to come and listen to everybody as well, and it's an investment that you can do, which will give you very good returns, I'm sure. So please encourage everybody to join in. Of course, recording is there, but being in person is very different experience than on program. So please encourage everybody and please ask others also to join. And this is now on auto. It's also on automated mode now, huh? Shajan, you don't have people just.
Wahid, but how will we search for the older, previous sessions? How will we search if I want the topic?
I'll send the details to you, Bindu.
Okay, thank you, Manal.
CETCPC.com. Okay, there's a website called CETCPC.com.
You have to pay money and register. Yeah.
Pay money.
No. As of now, it is free. After you cross 60, it will cost you $100 a day.
Then I am not joining. After 60, I don't have any pension, so I will not be joining.
Bindu, it's best to
ഈ ഷാജനും എഡ്വേർഡ് എന്നൊക്കെ പറയുന്ന ആൾക്കാരൊക്കെ ഞങ്ങള് കോളേജിൽ പഠിക്കുമ്പോ അയ്യോ ദൂരത്തിൽ നിന്ന് കണ്ടിട്ട് ഈ ബുദ്ധിജീവിയുടെ അടുത്തൊക്കെ ഞങ്ങൾ പോവാറേ ഉണ്ടായിരുന്നില്ല. ലൈക്ക് ദാറ്റ്.
ഷാജൻ വെള്ളച്ചാട്ടം കാണാൻ പോയിട്ട് അപ്പുറത്തേക്ക് തിരിഞ്ഞിരുന്ന ഒരു ഫോട്ടോ എന്റെ അടുത്തിരിപ്പുണ്ട്.
ഷാജൻ, എഡ്വേർഡ് ഇവരൊക്കെ അയ്യോ അടുത്ത പോലെ പോകാനുള്ള ഒരു ഇതുണ്ടായിരുന്നില്ല.
വഹീദ്, ഇവിടെയും ബിസിനസ് കൊണ്ടുവരരുത്, ഞങ്ങൾക്ക് കാശൊന്നും മുടക്കാനില്ല ഈ വയസ്സാം കാലത്ത്.
Okay, bye. Good night.
Okay, thank you guys.
Okay,
Thank you.
nice.
Thank
Yeah,
you.
nice talking to all. Bye.
Bye.
Thank you.
Thank you.